What's up, guys? Another quick video here for AP Stats on cumulative relative frequency graphs. Ugh, a really long, ugly name for something that's actually pretty simple. All right, so this is basically a graph of percentiles. So one final way that we could display quantitative data is with a cumulative relative frequency graph. It's a graph of percentiles. They're also known as ogives. Now, I don't want to go too much into why they're called ogives, but first off, these graphs could look all different kinds of ways, but one particular way that a lot of them look looks like some old architecture or something that's called an ogif. I don't really know, but that's kind of where the name comes from, but that's really not official, but a lot of people do call them ogives or ogives. I'm not sure how you pronounce that. Anyway, here we plot a point that corresponds to the percentile for that value. This shows how the data builds up. Obviously, bigger values are going to have bigger percentiles. Lower values are going to have lower percentiles. If you're wondering what's a percentile, maybe we should review that real quick. A value's percentile is the percentage of data at or below that value. So, for example, if an 18-month-old baby's weight of 28 pounds puts him at the 88th percentile, that means 88% of all 18-month-olds weigh less than or equal to 28 pounds. So every value in a data set has its very own percentile. It's simply the percentage of data that is at or below that value. So we're going to look at one of these ogives, cumulative relative frequency graphs, and we're going to answer a lot of questions, and you're going to like it, I think. But let's give an example that we have some foundation for what the heck we're about to look at. So we looked at a random sample of 750 people, and they were selected as they were leaving a convenience store in a suburban town. And they were simply asked, how much money did you just spend at the convenience store on groceries or whatever it was, candy bars, who knows what people buy at a convenience store. The cumulative relative frequency chart shows on the x-axis intervals of dollar amounts, because that's what our data is. It's the dollars that these 750 people spent at the grocery store or convenience store. And on the y-axis, the corresponding percentile for each of those dollar amounts. So let's take a quick look here. So again, on the x-axis, we see the amount of money that's in dollars. So 10, 20, 30, 40, 50, 60, 70, 80, all the way up, right? And on the left side here, this is the percentiles, cumulative relative frequency. Those are percentiles. Now, these graphs kind of look funky. A lot of people say, oh, that's a line graph. No, it's not. It's right based on this showing percentiles, very different. But again, every dot, let's just kind of pick a dot real quick. So this dot, let's go with this one right here. This dot right here looks to be about, if we track it over, that corresponds to $40. If we track it over, that looks to be at about the 25th percentile. So at the $40 mark, we have the 25th percentile. What that tells me is that of all the 750 people that were at the convenience store that I surveyed, 25% of them spent $40 or less dollars. 25% spent $40 or less dollars. And let's grab another one right here. Let's grab this one right here. This one looks to be at $90. So once again, that point is at 90, comma, looks like, I got a little estimating there. Maybe we'll call it the 92nd percentile. That means that 92% of all people I surveyed spent under 90 or equal to $90. And then as you build up, you'll always end at the 100th percentile. This would be obviously my max value. My max value must have been $130, and it would make sense that that was my max. 100% of my data was at or below the max. Duh. Likewise, the min is where you would start. 0% of people spent under $10. So that would be my minimum. So lots of cool stuff here. And we see a lot of really cool things. So what are some things that we could find in these plots? Well, we know that the median, Q1 and Q3, are also known as percentiles. The median is the 50th percentile, 50% below. Q1 is the 25th percentile, 25% below. Q3 is the 75th percentile, 75% below. So it looks like $40 was our Q1. Again, we matched that up. 25% of data was below it. That's Q1. The 75th percentile would be right about here. And if we follow that over and then we track that down, we're doing our best to estimate this. Maybe, let's see, if this is 70, this is 75, maybe $77. You're just trying to estimate. But that mark right there, I'll kind of drop that down. That would be Q3. Get about $77, $78, kind of estimating a little bit. And that would be meaning that 75% of the customers spent less than $77. And we could also find the median. The median is the 50th percentile. Track that over and come down. That looks to be right at $65. So 50% of people spent less than $65, 50% spent more. Now, anytime you're talking about a percentile, the definition of a percentile is the percentage at or below, but you guys are pretty good at math in your head. If you know a percentile, you automatically also know the percent above. For example, the third quartile. The third quartile is the 75th percentile, meaning 75% of people spent under $77, but common sense tells me that 25% spent more. Same thing here with this point we looked at right here, the 90, the 92nd percentile. 92nd percentile tells me that 92% of people spent less or equal to $90. Well, that means 8% of people spent more than $90 at the convenience store that day. We also could see where larger or smaller proportions of data fall in the distribution based on the slope of the line segments. Where you see a longer line segment or a steeper line segment, that means more data was in that range. So just for sake of being able to see all this a little bit nicer, I'm going to kind of go ahead and erase a lot of the stuff that we've drawn here just to kind of clean it up a little bit. Sorry. Okay, there we go. That's good enough. All right, so in an area, for example, like right here, from 70 to 80, that was a pretty steep change, right? We went from about the 58th percentile all the way up to about the 81st percentile. So here we were at the 81st percentile. At 70, we're about the 58th percentile. That's a huge jump. That's a jump of about 23%, right? 58 to 81, about 23%. That means 23% of our data fell from $70 to $80. So 23% of people spent $70 to $80. So the steepness of that line is showing me that a lot of people, a big chunk, fell in that data. Whereas a less steep line, like right here from 100 to 110, that was a very small change, maybe from like the 93rd percentile to the, 97th percentile. So again, that's only about 4% of people in that range, 100 to 110. So steeper means more people, more data were in that range. So you could almost kind of think of like what a histogram would look like. From 10 to 20, there'd be a smaller amount of people. 20 to 30, that's a good chunk. About 10% of people would be there. And then again, from 60 to 70, we see a pretty big chunk. That'd be a higher bar in my histogram. 70 to 80, that'd be kind of, so again, if I'm kind of drawing this histogram out, 10 to 20 is only a small chunk. 20 to 30 is a little bigger chunk. 30 to 40 is about the same. And then 50 to 60 is a little bit smaller. 60 to 70 is a pretty big chunk. 70 to 80 was a big chunk. And then it kind of gets smaller from there as it's not so steep. So you kind of get a feel for the amount of data, the percentage of data within each chunk. Since we could find the Q1 and the Q3, we could definitely calculate the IQR, because IQR is simply Q3 minus Q1. So if we know Q3 and we know Q1, subtract them. And again, I actually already mentioned this. We can get a really good feel for the shape of the distribution of the data as well by looking at one of these. In fact, let's actually look at three more here. Here are 3 percentiles. I kind of want to look at these so you could, cumulative relative frequency charts. Now, they're all based on the same data range on the x-axis, but we notice some very different lines going on here, right? So if we look at this first one right here, this one actually looks pretty symmetric. How do I know it looks symmetric? Well, the lower bins are, I'm thinking about drawing a histogram, right? The first bin's kind of low, not a whole lot of data there, not very steep. Then the next bin, that's pretty steep. We got a big chunk of data there. Then we got a big chunk of data. This steepness right here is showing me that there's a big amount of data in that bin. And then it actually starts to drop off again, not so steep and almost flat, almost fat. It's very little data there. So we see that that would be symmetric. Graph number 2 here, this one would actually be skewed to the left. Why? Again, it builds up. Look, very less, the slope is very small. So that's going to be not a whole lot of data, not a whole lot of data. But then as we move from left to right, we start to see the steepness of those lines increase. And we end with, a big chunk of data is here at the end. So from 50.5 to 60.5, we see a big chunk of data in that range. And then this one over here, this third one, this one would be skewed. Oh, by the way, so that was skewed left, right? This one would be skewed right. In the beginning is where we see the big chunks of data. We see those big slopes in the beginning, big chunks of data. And then as the data gets bigger, we start to see less and less values in those intervals. So that would be skewed to the right. So again, when we think about shape, you're thinking about the steepness within each interval is really showing you that there's more data in that interval based on subtracting and looking at the percentages there. All right, so let's go back to our I keep wanting to call them OGIVs or OGIVs, but really they're cumulative relative frequency charts. So this is the original one I showed you about how much money people spend to store. But let's actually answer some questions from this now. So the first question says, what does the dot at 30, 0.16 indicate? So at 30, we're about 0.16 is what they're estimating this dot to be. So remember, 30 is the dollar amount, and the 0.16 is the percentile. So that means that 16% of customers spent, sorry if I'm missing handwriting, $30 or less. Now, common sense tells me that that means 84% spent more than $30. What proportion of people spent between 70 and 80? So once again, just find the dot for 70. We estimated that to be around 0.58 or the 58th percentile. Find the dot at 80. We estimated that to be about 0.81 or the 81st percentile. So in between there would be 23% of data, just subtracting those values, 23% of data in between. Now, what does the flat line between 110 and 120 indicate? That means that there's no data there. No people spent between 110 to 120 because we didn't change. We were at about the 98th percentile for both of those. So that means from 110, about 0.98, 98% of people were under 110. Well, at 120 was the same thing, 0.98. 98% of people spent less than 120. So the fact that we flatlined there simply means that there was no data there. That'd be like an empty bin if we were making a histogram. What percent of people spent over $80? Now remember, percentiles are under, but we could always find the over if we just use our brains for a hot second. So 80, remember, we found at 80, if we connect the dot there at 80, that was the 81st percentile. So that means 81% of people spent 80 or less. Well, that means 19% of people spent over $80. Makes sense, right? All right, finally, how many people that were surveyed spent over? So the previous question said, what percentage of people? Well, 81% are below 80, 19% above. So how do you figure out how many? Well, this is where we got to do a little bit of math. We had 750 total people in our survey. That was in the directions. And we just answered that 19% spent over $80. So you're just going to grab a calculator and we're going to do some simple math here. $750, oh my gosh, not 750, 750 people times 0.19 equals about 142.5 people. Now, you can't have a 0.5 of a person, so we probably round that up to 143 people. There must have been some rounding going on when we made this, and that's totally normal. So 143 people, 19% spent over $80. So those are some of the questions that we can ask you. Those are some of the typical questions that you're going to be asked when you see one of these. But pretty cool, pretty simple, pretty basic. They show percentile ranks for each mark that is labeled. And even for the points that are not labeled, you could do some estimating, right? So if somebody asks you about, $37, well, you'd say, okay, here's 30, here's 35, here's 40, 37 would be right about here, followed over. That looks to be maybe about the 21st percentile, somewhere around 21st, 22nd percentile. So even if it's not labeled, you could still look it up. You just got to do a little bit of estimating. Pretty cool, pretty simple. We love charts like these. Again, call them ogives, ogives. That's kind of a loose nickname for them, but cumulative relative frequency charts. They're really cool, provide a lot of really good information.